Welcome to this model. In this model, we'll be looking into the measurement of cardiac output. Cardiac output is the amount of blood delivered by the heart to the aorta per minute. And there are various methods for measuring the cardiac output. That is fixed method, dilution, and indicator dilution, and thermal dilution, and impedance change method. So in direct methods, the cardiac output is measured by the stroke volume by the use of an electromagnetic flow probe placed on the aorta and multiplying it by the heart rate. This method involves in surgery, so it is not preferred in routine applications. Now let us see the fixed method. And in fixed method, the cardiac output is determined by analysis of the gas keeping of the organism. Cardiac output is measured by continuously infusing oxygen in and out of the blood, and also measure the amount of oxygen before and after its passage. Let I be the amount of infused or removed oxygen per unit time. I is equal to the difference between the amount in blood arriving at and departing from it. And I is given by CAQ minus CVQ. CAQ is the concentration in aorta and CVQ is concentration in veins. And the flow rate F is given by F is equal to dm by dt divided by Ca minus Cv, where F is the blood flow in liters per minute, dm by dt is the consumption of O2 in liters per minute, and Ca is the arterial concentration of oxygen in liters per minute, and Cv is the venous concentration of oxygen in liters per minute. So in this diagram, it shows that blood returning to the heart from the upper half of the body has a different concentration of oxygen from the blood returning from the lower half. So the oxygen concentration is measured by the spirometer. The arterial and venous concentration difference is measured by drawing samples through catheters placed in the artery and in the pulmonary artery, as you can see in this diagram. So the main advantages of fixed method is it is non-toxic because the indicator is oxygen only. It is a normal metabolite that is partially removed as blood passes through the systemic capillaries. The cardiac output must be constant over several minutes so that the investigator can obtain the slope of the curve for oxygen consumption. The presence of the catheter causes a negligible change in the cardiac output. And the next method is indicator dilution method. It is one of the most popular method and it employs several types of indicators. Two methods are generally employed for introducing the indicator in the bloodstream. Continuous infusion method, but it is not widely used due to the indicator recirculate process. Bolus injection method. In this method, amount of blood known by an indicator using dye and it is administered into the circulation. Indicator was injected into a large vein through right heart, lungs, left heart, and then the indicator appears in the arterial circulation. So the presence of indicator in the peripheral artery is detected by a transducer and it will be displayed on the chart recorder. Therefore, the cardiac output on chart is in curve form and that curve is called dilution curve. And this diagram shows the procedure for indicator dilution. So here an indicator I is mixed with the blood with a known injection rate and the concentration of the indicator is measured after mixing. Then the flow F is given by I by C. I as the indicator which is milligrams per minute and C is given in milligrams per liter. So after passing through the right heart, lungs and left heart, the indicator appears in the arterial circulation. So the output of the detector will be directly proportional to the concentration of the indicator. So during the first circulation period, the indicator would mix up with the blood in a small quantity, and after that there is a rapid change of concentration. So this is given by the rising portion of the dilution curve. After reaching maximum, the concentration of the indicator is decreased exponentially. A second peak would then appear, and when the indicator is completely mixed up with the blood, the curve becomes parallel with the time axis. So suppose if M0 is the quantity of an indicator which is added to a volume of V, then the concentration C is given by C is equal to M0 by V. If an additional quantity of M is added and the incremental increase in concentration is given by delta C is equal to M by V. So this diagram shows the dilution curve, which gives a peak value after some duration for mixing, and then a second peak will appear at a recirculation period. And the next method what we are going to see is here is dye dilution method. In dye dilution method, a common it is a colored dye that is, for example, indocyanine green will be added with the blood, and it meets the necessary requirements of indicator, and this dye is preferred because of its property of absorbing light in 800 nanometer. The concentration of the cordial green is measured with the help of infrared photocell transducer. So densitometer is used for the quantitative measurement of dye concentration, and in order to avoid the formation of bubbles, a PART type tube should be flushed with a solution of silicon and a flow rate of 40 ml per minute is preferred in order to get short response time as possible for the sampling catheter. So the sampling syringe has a volume of 50 ml per minute, and the output of the photocell is connected to low drift amplifier. It has high input impedance and low output impedance. So the amplification will be directly proportional to the resistance value of the potentiometer. A potentiometer records the amplified signal on a 200 mm wide recording paper with a speed of 10 mm per second. And the dye is available as a liquid that is diluted in isotonic saline and injected directly through a catheter and usually in the pulmonary artery. About 50% of the dye is excreted by the kidneys in the first 10 minutes, so repeat determinations are possible. So the plot curve for the concentration will draw the blood from the catheter placed in a femoral or brachial artery. Blood is drawn through a calorimeter cuvette which continuously measures the concentration of dye using the principle of absorption photometry. And next we will see about the thermal dilution method. A thermal indicator will produce a resultant temperature change in the pulmonary artery, and the integral is inversely proportional to the cardiac output. So the system calibration is based on the use of injection of 10 ml of 5% dextrose solution at a room temperature in the range of 18 to 28 degrees Celsius. So in this range, the injected temperature is measured to an accuracy of plus or minus 0.2 degrees Celsius and displayed on a meter. And a solution of 5% dextrose is in water at room temperature first is injected. The injected temperature is sensed by a thermistor, and the temperature difference between the injected temperature and the blood circulating in the pulmonary artery is measured. So then it is given to the linearizing amplifier. It works on the principle of fixed resistance with a suitable value that is placed in parallel with the thermistor. So the reduction in temperature of the pulmonary artery is integrated with respect to time, and the blood flow in the pulmonary artery is computed electronically by a computer. The integrator responds to a delta T, and that is the incremental temperature of the blood injected into the mixture, and signal corresponding to maximum temperature change of typically 0.3 degrees Celsius with reference to a TB. It may vary from one patient to another to over a range of 30 to 40 degrees Celsius. Then the summing, multiplication, division operations required for the evaluation of cardiac output are performed by a simple computing circuit by a computer. So the timer control unit generates the switching signal necessary for proper integration. And the cardiac output will be displayed in two ranges, that is 0 to 10 liters per minute and 10 to 20 liters per minute. And the main advantages of this thermal dilution method is, and the techniques, these techniques will avoid the introduction of fluids and thereby reduce the risk of fluid overload and sepsis. And the last method of measuring the cardiac output is the impedance change method. And in this method, the cardiac output is determined by electronically. Here, probe method is used. For example, electrode pairs 1 and 4 is used as current electrode, and electrode pairs 2 and 3 is used to pick up the voltage from across the thorax. When a consistent current of 100 kHz is applied between 1 and 4, the impedance is 25, and this diminishes to with each systole. And the voltage signals due to change in impedance is amplified and demodulated to obtain a Z. And this is shown in this figure. So what we see here is 1 and 4 are current electrodes, and 2 and 3 are voltage electrodes, which are picked by the voltage picked by the electrodes are given to amplifier and a demodulator circuit and a differentiator. Thank you.